Hi, it's Dr. Allen here. I wanted to put together a short video to help you with some of the challenges of this week's lab on the determination of vitamin C concentration. As you open up your lab kit and find all your new materials, you may find that you need help with some aspects of the lab. It's up to you to follow all of the individual small instructions. I'm going to go over some of the bigger picture items that students tend to have trouble with. So the purpose of the experiment is to have an ascorbic acid solution and to determine its concentration. So you'll have an ample supply of water, so you'll fill your beaker with pure water, typically not tap water, typically bottled water or distilled water, and you'll have 3 cups labeled ascorbic acid, waste, where you can just dump everything conveniently, and then your unknown. So one of the first things you have to do, and you'll do this as soon as you're ready for the experiment, is prepare your ascorbic acid solution. So you have an ascorbic acid powder, and you need to weigh out 0.5 grams. You have a weigh boat and a balance. The weigh boat actually weighs over 2 grams, so you can put that on the balance, and you'll be on a flat surface. And then on your balance, there's a button that says tare. So after you turn it on, and you put this on, the weigh boat on, and you hit tare, they will have a reading of 0. If the reading fluctuates too much, there's too much draft in the room, and you can set up a box or some sort of shield to help with the draft. But you press the tare button, the reading will say 0. Then you can add the 0.5 grams of your ascorbic acid, and then you can transfer that to the ascorbic acid cup and fill it with the amount of water that the instructions tell you to fill it with, and dissolve it, and that's your ascorbic acid solution that you'll be working with for all aspects of the experiment. Then you have to be able to prepare your unknown. So this, you won't actually know the full concentration. The purpose of the experiment is to determine this concentration. So the way we're going to do that is take the smaller medicine cup, take the ascorbic acid solution, fill it about 50% or a little over halfway in the cup, pour that into the unknown cup, and then dilute it with the amount of water that the instructions call for. And then that's your unknown. You really don't know what that concentration is because nothing was really measured. This one we know about how much. If you followed instructions, we will make assumptions about this concentration. All right, so those are the solutions that you'll use to prepare samples to be titrated. Your titrant is the DC-PIP, comes in a brown bottle. You have to prepare this solution. The directions call for a certain amount of water to be added directly to this bottle, and you put the top back on and shake it up to get it dissolved, and then it's ready to go. It's a very dark blue solution. It will stain, so be very careful with it. All right, so then you'll need to continue reading the instructions, prepare your sample. It will have you go through something quick to show you what the endpoint will look like. And then you'll set up your samples and you will start collecting data. All right, so your data table looks something like this. And the first measurement often causes a lot of confusion. So your first sample that you titrate is intended to have basically no ascorbic acid in it, a concentration of 0. Therefore, when you're titrating with the titrant, it shouldn't take any. There's nothing to titrate. So it's going to turn blue immediately with the first drop. So how does that look? Well, you have to know how to read your syringe. The syringe is intended to hold 5 mils. So you pull in 5 mils of the DC-PIP, and you're going for the edge of the plunger to be at 5 mils. We're not looking at the point, we're looking at the edge to read 5 mils. So we've got it full. So we're on our first full syringe. Mentally, I'm noting that I'm on my first one. And on that first sample, when I'm titrating, 1 drop, it's going to turn blue. So I'm still pretty much going to have 5 mils left. So on my data table, what that looks like is I only filled the syringe 1 time, so I started with 5 mils in my syringe. My unit is already in the title or in the heading of the table, so I do not put it next to the number. I added 1 drop, and I pretty much still have a reading of 5 mils. So the amount that I used for that sample is 5 minus 5 is 0 mils. Because something with 0 ascorbic acid in it should take 0 DC-PIP to titrate it. All right, so then you move on to your second sample. So you put that in the waste, you rinse everything out, and you're ready to go. Make sure that you're back to the 5 mil mark for your next sample. All right, I'm not going to fill this in yet because I don't know if I'm going to need more than 1 syringe full. But mentally, I'm starting with 5. It could be 10 or 15 if I have to refill. All right, so I start my titration. And I add and add and add. And let's say I get to, say I get to 2.2 left in my syringe. So I started with 5. I didn't have to refill, so I started with 5. When I got done, when my sample turned blue, I had 2.2 left in the syringe. That means I used 2.8 mils for my sample. All right, then you discard that one, and you start again. You get it refilled to 5, and I'm ready to start on my third sample. All right, so I start with 5, but I don't know if I'm going to have to refill. So I'm going to titrate, 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 add, and let's say I get down to 0.4. Okay, and I didn't have to refill. It turned blue with 1 syringe. So I started with 5 mils. I got all the way down to 0.40 mils, and that means that I used 4.6 mils in that titration. All right, so my guess is when I increase to a higher concentration of acid that I'm probably going to use more than 1 syringe full this next time. All right, so I refill to the 5 mil mark with the dark blue DCPIP, and I titrate my sample. And I'm titrating, I'm mixing it up, making sure it's mixed really well, and I'm titrating. And I use all of it, and I'm still not done. So I refill all the way to 5. All right, and then I start again. So now I know that I'm on my second syringe. So I'm starting with a total of 10 mils, and I'm going to titrate and titrate, and I get to about 3.1. So since I had to refill once, that means I started with 10 mils this time, and I got all the way down to 3.1. All right, so 10 minus 3.1 is 6.90. That's how much I used in that titration. And then you continue on with the next trial. And so I need to refill all the way to 5. Start my titration. And I'm even more concentrated this time, so I know I'm probably going to use more than 1. So I'm doing the fast cooking show version of this experiment. So I used 1 syringe. I refill to 5. And then I titrate, and let's say I get all the way down to 0.9. All right, so I had to refill, so that means I started with 10, I got down to 0.9, and that means I have left over that I used 9.1 in that titration. So you have the potential to use a lot of the DCPIP in this experiment, but remember, I think you have about 100 mils, so you see that you're going to be okay, but don't waste any of your titrant. Reuse it if it's still left in the syringe. All right, and then you need to do the 3 unknowns. So for these, you'll pull from your unknown, and you will titrate those. So I'm just going to do that one time and say it takes one syringe. I start with 5, and I got down to 3.1, and that means that I used 1.9 for my unknown. And then you would do this one, and you do it 3 times. They should be similar values, but not exactly the same, because it's data, and it would be average to determine the unknown. All right, so the top portion of this is known. You know the acid concentration, and you know how much DCPIP that you used. All right, so you're going to do a graph, and these numbers are going to be graphed on the x-axis, and these numbers are going to be graphed on the y-axis. Not the unknown numbers, just the data that we know. You'll graph that and to determine a best fit equation of the line. And so I've done that for my data here, and my data is totally made up. Okay. and you should get something like this. So I have what I entered into Excel, I spit out my graph, and I got this equation of the line. So now this should be linear, and now I have a relationship that if I go and do another titration for something where I don't know the concentration, I can plug in the volume, and it's related to the concentration. All right, so we have y equals 4.46 x plus 0.22. Y is volume of the DCPIP, and x is the acid concentration. So for my first unknown trial, I used 1.9 mils of the DCPIP. So 1.9 equals 4.46 x plus 0.22. If I solve for x, then I will have my unknown acid concentration. So first I'm going to subtract 0.22 from both sides. Get 1.68 equals 4.46x. And then I'm going to divide both sides by 4.46. And I get 0.38 as my concentration. So that's the overview of the lab. I have two more unknown trials where I would plug in and solve. But you'll be asked to enter the slope value into WebAssign and the y-intercept value into WebAssign, and that will tell you whether you have determined your equation correctly. So let me know if you have any problems with that. Again, the biggest thing was making sure you take that data correctly and read your volumes correctly. So good luck with the experiment. Let me know if you have any questions.